Well, welcome back from the break. I hope you enjoyed it and had some good beverage or whatever you had. Unfortunately, John Constable couldn't appear today, and instead of him, Sergey Bolotov from Canada will give a presentation here about the Windrotor Bolotov at degrees north. Are you there, Sergey? You are there, but you're muted.
Hello.
Oh, that's much better. That's much better.
Nice to meet you. All right.
Nice meeting you. Welcome.
Now I just want to switch on my computer and show beginning of my presentation. Okay, so thank you for inviting me. I'm saying hello to everyone. So my presentations is related to them. Do you see the screen?
Yeah, we see you. Not the screen yet.
Not yet? Oh,
no.
Okay, wait a minute, please. So I'll start sharing, right? Hello? All right?
Not yet.
Hello?
Here we go. Now there's a full screen.
All right. So my presentations is regarding the solely question and turbine building its vertical axis wind turbine. Vertical axis wind turbine, it has a name the same, like a WRTB. It's because of we spent 20 years doing the same, and for our own established independent wind energy company, and we have done lots of R&D and manufacturing and all this related stuff. So I want to point out some words that not comes from the like a general information, but we call it dynamic vertical axis wind turbine, development, production, and new promising solutions. So it just from history, we are published in Innovative Wind Turbines in guidebook by Von Nelson. This is wind turbines and me. The turbine looks like a cylinder, and we see some amazing features of this turbine. It's a high efficient wind turbine and energy harvesting, and environmentally friendly structure. No problem for any birds or animals. It's reliable turbines for charging batteries in the autonomous power system in a fully off-grid sites. The system have been checked for many years. It's a modular, secure, noiseless turbine that works now in all climate zones. It's an industrial and commercial approach to the use of turbines and compact hybrid system wind-sun. We were focused on solving some difficulties between mechanic, aerodynamic, electric, electronics parts of every turbine that they have. And because this turbine is vertical, is for sure omnidirectional, and we mastered the system that very smoothly and dynamic works in all weather conditions and any directions changing at time. Nowadays, since 1994, we mastered the R&D lab and 3 production manufacturing technologies. We manufacture steel one, It's very like a ecological wind turbines. It has nothing, just steel, and let's say in 20, 30 years, it's no pollution predictable from our activity. And another is plastic. Plastic, we start to manufacture this plastic because of like a weather condition in subtropical areas. For the north area, we use steel one. So the technology patented, we have priority since 2001, and there are many, like 10, 12 patents on this turbine. We passed lots of testing and in its wind tunnel in Korea Space Research Energy Institute, and we confirmed the results what we are showing. So the last our solutions was mastered to design the controllers it's not controller, but itself it's like an energy harvester. So we can easy charge batteries, 24 or 48 volts. It's lead batteries, and also we can charge big lithium batteries. And so a field test of the turbine showing the results that our turbine is very good correlated with kinetic energy of wind. So it's graphs, it's minutes, how the, let's say this is 3 kilowatt wind turbine. So it's showing 3.5 stable work at the wind speed that we're showing in the theoretical power curve. And so we passed many typhoons testing, and in this is showing South Korea, some islands, and it's a plastic wind turbine. It's, you see, 52 meters per second. And this turbine showed very good results. It's not unstoppable device. So now we designed about four or five different models of the wind turbine with different diameters and different kilowatts. So it's for sure a small wind turbine. It might be, it's better say it's a micro wind turbine, but this turbine is working like a tractor. So it's not a bolide, but it's a very good tractor, good harvester, and very reliable. And we estimate that it compare with other wind turbines at the same place. Might be there are some very good turbines in the world, but we compare it with existed turbines around, and we harvested at least 1.5 more energy from the same weather conditions. This turbine has no vibration and noise, and it's allowed for installation in tower structures like telecommunication. So here it is, some technical description with detailed information. So we can charge 48 volts using inverters. It's the other parts like a hybrid, it's no problem, but we focused on the wind turbine. It's steel structure. It has like a weight about 600 kilos or 1 ton. It's just typical weight. It's not like a light, but it's very durable and reliable. So if one the turbines installed, no problem with exploitation at all. We see a rated wind speed 13 meters, low noise -50 and +50 absolutely tested. And it's tested also in like a difficult frosty weather condition. What else I can show you here? It's mostly off-grid, but we can design on-grid, but using batteries because of small wind turbine. It's a model S2, WRTB S2. It's like how it looks like. It's this is a size. It's just shipping. Last week we shipped several wind turbines. It's the size of it. It's a plastic cylinder, and it just generally speaking, it's 5.5 meters long structure. This is a description more detailed. So we have a peak power at 5 kilowatt and rated 3.5, and the turbine working non-stop. That's one of the. It's not closing or like any functions related to stop or limit the rotation are absent. We have for sure a small small brake like electric brake, but it's not just for surviving, for exploitation. We have installed many turbines. Here it is some critical installation in the northern part. It's mostly Arctic, and remote islands. This turbine accepted and welcomed for lighthouses, so for independent and off-grid exploitation. Let's say this wind turbine that the screen working without any maintenance, like it's possible to allocate the, and it's working in all climatic zones. So we have designing some structures that useful for telcos and other supplies. They need to have some stable and stable structure. So that's the point. So also I would like to show you a small video. This is a video of 40 kilowatt hybrid station. Every tower, the wind power for each tower, it's 10 kilowatt plus 6 kilowatt of solar. So it's 16 each tower. This hybrid station was installed in 2013. So it's also working in operation like 8 years. Okay, I just might be another one. It's a fishery village in tropics in Korea. This is our manufacturing facility. So that's it. That's all my presentation.
Thank you very much, Sergey. It's been a pleasure, interesting. Are there any questions or comments to Sergey Bolotov?
They are. I have a question.
Mm-hmm.
I want to know the performance in the wind turbine around the tropical environment, like the Caribbean. You know, here we have to expose to the several hazards with the environment that like tropical storms frequently. With the mean and one tropical storm with 2 or 3 years is the rate in the Caribbean. So in this order, can you please about the performance to the low wind and speed? And I want to know about the material, the plastic to build the wind turbine. The plastic is the thermostable or is like the recycled material or no?
This material is like it's very close to the another explanation. It's FRP plastic. This kind of plastic is using in boat building. So it has the same structure and durability like a boat. So we have no problem with like a salty environment exploitation or sun ray exploitation. It's exactly built in South Korea, and they actually very close condition to Caribbean. I think it's warm, like a humid, salty area, and so it's for sure suitable for Caribbean.
Okay, thank you.
Well, if not any more comments or questions, I would say thank you very much to you, Sergey Bolotov. It has been interesting. And there is one question more from Svenine Olsen.
Yes. Very nice to see, Sergey. I've always had some trouble in documenting what's going on in a vertical axis turbine. And I would very much appreciate it if you could tell me what's going on when you are experiencing 20 meters per second. Is it stalling or how do you limit the power?
The turbine is built is just for all weather condition. So the structure of like a physical structure, mechanical structure is designed not to be sensitive to the over limiting, like what's saying in the classical wind turbines, like a 20 meters per second, no problem with this. So the rotor will rotate with the maximum wind speed, but it's not over limiting. And we have, let's say, speed coefficient quite low. It's 1.2. So we do not experience with mechanical problems. No vibration. It's rotating with 15 meters per second, and for 25 per second with the same speed. But it's the only current is changing. The load is like increasing, but no no problem with yaw or some mechanism in this device. So it's working with all weather conditions. We are not switching off the power system. As I showed in my presentation, even hurricane or typhoon with 52 meters per second was passing over the wind turbines. In this area we have about 10 wind turbines, and nothing happened with all of them. But it showed very good current. Like it was, the system was working at, let's say, for 5 kilowatt, and we are good in this harsh area. Even it's also the same weather condition in northern territory or Arctic. We can't stop it because the weather is changing so fast, and so we don't have any brake system that holding rotation. We have the electric brakes that like a little bit limit or distribute energy from generation, like between batteries and dump load. The only things. But if the batteries are empty, it's continuing charging the batteries with high current. And we have specially designed the controller. And it's like a smart controller. So that's my answer. We don't have any brake system.
No, but I was more interested in what's going on from an aerodynamic perspective. Are we talking a drag type turbine? Are we talking an aerodynamic turbine? Do you have profiles? How do you get it to reduce itself in efficiency when the wind gets too high?
It is a multi-blade. It's a structure. Two parts. It's and multi-blade stator. So and structure, and if any gust occur, they are not. So a little bit different explanation. So the rotor of the wind turbine always working in the predictable wind flow. So the stator is limiting the gusts, and it's like a classical aircraft turbine. So the wind is coming in prepared for processing, like energy is coming the same way with any wind speed.
I hope that you got most of it, because the line has been very unstable, and some of us can only have heard half of it, and the video was also frozen sometimes. But anyhow, I hope we can take it up later, because to keep the schedule, we have to go on. But thank you very much, Sergey Bolotov.